Okay, I just having a very quick walkthrough of this example 3. So the figures below shows the one-line diagram of the three-phase system. So these are all the parameters, like the nameplate rated values for all these equipment: generators, full transformers, and a motor. And we're going to select a common base. So we usually select the power and the voltage at the base at one particular zone. So later I will show you there will be three zones, three voltage levels we select for one part. And this is on the generator side for this question. Okay, and then we're going to solve this question, bring everything into a new per unit system, because here you can see there are some per unit system, per unit number is a ratio being given for these equipment. These are for respective power and voltage level, but we want to convert them all into this new base. Okay, that's actually the whole purpose of this question. So if this per unit number being given, then we're gonna use the equation provided in the question like this. We use the old per unit system, multiply a ratio, something like that, the ratio. I'm gonna explain that later. And if the absolute value being given, for example, this reactance being given, then we can just divide this by the base Z. Okay, I'm gonna show this as well. Here I draw the whole circuits, and in black color I write down everything from the given. Okay, for example, generator is 22 kilovolts. That's the voltage level. 0.18 is a per unit value for the impedance, for the reactance of the generator. Okay, and the T1, T2, T3 are the same. I write down there. We separate it into three regions. So first one, you can see from the middle, left-hand side of the transformer and the generator, and left-hand side of T3, they are one region. Okay, they are one voltage level. After that, this is another voltage level. Okay, you can see this is 10-time transformer. And step down, so the right-hand side of T2, right-hand side of T4, and all these two components, equipments, are another voltage level, and this transmission line is another voltage level. Okay, you can see there are four regions, and we've been given for one region, which is a generator side, the new base. Okay, so we're going to use this to calculate the basis for the other three regions. Okay, one being pointed, assigned, and based on that, we calculate a base for the other region. So in this first region being given, S is 100 mega VA, and the S will be used across all the regions. And the voltage here is 22 kV. You can see they are kind of a coincidence. The rated voltage is also 22. In some cases, they are not matched. We can do that as well. So based on that, we can figure out the S base for region 2 is still the same. The voltage base for region 2, V base 2, will be using this ratio. So this is 22, then using this ratio, we got a 220. Okay, and then we can calculate the base for the impedance, Z base, for this region is V squared over S. Okay, and then we got this one. And one step forward, you got this absolute value for the reactance, 48.4 omega, divided by the base, then the PU value for this one, 0.1. Okay, we're going to convert this one later, these ones later, but I'm going to move to the next base, V3, V base 3, so 22 at the front. This ratio is 5 times larger, so we got a 110 kilovolts. Okay, and the base is again v squared over s. We got this one. And using this absolute real impedance value divided by the base, you got the per unit value for this section, the impedance. Okay, the last region, again, S is still 100 megawatt, meg VA, and the voltage is 11 because this is 220 and 20 times smaller, okay? Because of this transformer, you got 11 kV. Same thing happens here. So because they're same bus, it has to be exactly the same. So 100, 10 times smaller, 110, 10 times smaller, that's 11 kV, okay? Then we can calculate the base for this region is that, okay? And this XM, that reactance is given in the per unit system. We don't use this way to calculate new per unit system. Then we're gonna move to the next part, is how you convert the old per unit number to a new per unit number. Okay, that's the given 0.18. Okay, 0.18 if you remember here. Okay, then we multiply with the ratio is the old base voltage divided by the new base voltage. In our case, up until the motor, everything is actually the same. So for generator, the new base is 22K. The nominal, the old base is 22K, so they cancelled. Okay, for this term, squared is still 1, but the base new is 100. The old base is 90. Okay, so the ratio is 100 over 90. So 0.18 multiply with that, you got 0.2. Same thing here. The new base is across everything for the power is 100. The old base for T1 is 50. Okay, so that's why we have this new ratio. Okay, same thing happens for T2, T3, T4. I'm gonna skip that. For the motor, okay, a bit difference. The given is 0.18, you can see from here. Okay, and the nominal voltage is 10.45, but the new base for this region is 11, so that's a bit of difference. So you do the old voltage base, new voltage base, and square, multiply with the new power, that's the old power. You do the calculation, that's the new per unit number for the reactance for the motor. Okay. And for the load is a bit different. The load, the apparent power being given, the voltage level being given, and the power factor being given is a lagging power factor. And the Z absolute value, okay, equals to V squared over S. Okay, and then we have this nominated voltage square divided by 57. Okay, there's a K squared, there's an M, so they also canceled as well, million, okay? And for the lagging power factor, so that means the current is a lag of the voltage. If the voltage angle is 0 as a reference, then the current should be negative angle, phase angle, right? But the Z will be a positive because I equal to V over Z, so Z got a positive, so that's where you got this. Okay, we already got the magnitude from here. Then you got your angle from the power factor. So you have this Z equal to this number. Okay, and these are the real number. These are not per unit system. Then you use this one divided by the base 4. Where is the base 4? We calculate the base 4 using the V squared over S. Okay. So, and that's everything for this one.